So, hello students, welcome to this online typing class for CM2 students, and this is class 2. So, in the previous class we basically discussed about basic MS Word shortcuts, and why I discussed basic MS Word shortcuts even in even in paper like CM2. This is because there are some students who might be giving a typing exam after a very long time or a gap of 1 or 2 years, and they may find some difficulty in typing their answers in MS Word. So, what they can do is they can go through my first video in which we have covered some basic MS Word shortcuts, and they can use those efficiently to type their answers. Okay. Along with that, we also covered a question or two from the chapter that is utility theory, and we did typing for that. So, if you guys have not yet watched that video and you are done with your utility theory in the theory portion, so please make sure to watch that video. So, basically in this class we are moving forward with our further chapters, which is we would be covering the chapter measures of investment risk. This chapter basically contains different types of investment risk measures such as VAR, tail VAR, conditional VAR, and since there are some integration terms and there are some different notation for these measures, students find it a little difficult to type. So, no worries, we are with you guys. So, in this video I would try to cover such a question that covers almost all types of measures. So, do not worry. Again a reminder, this is not a technical class, we would only be covering the typing efficiency, and we won't be covering any concepts. So, please make sure to refer to the conceptual classes to learn through the concepts. Okay? And one more thing, again a reminder that both the institutes allow the use of both the approaches, equationator approach and normal approach. So, again I would be doing a few parts like few measures from the normal approach, few measures from the equationator approach. So, suit yourself comfortably, whatever suits you, use that approach or use the combination, that is completely up to you. So, yes, let us get started with this class. Let us open the mat and let us see. So, yes, this is a question. An investment is contemplating an investment with return of pound R, where R is itna and N is itna, random variable. Calculate. Look, we are covering almost all of the investment measures. We are covering variance, semi-variance, shortfall probability, VAR and tail VAR, okay, and conditional VAR as well. So, this is a very good question. We would try to cover this question in our class. So, let us start with mentioning all the information we basically have. Let me increase the display. I hope this is okay. Yeah. So, let us start with our question 4 point. This is basically chapter 3.5. Okay. So, given that we will start with what we have been given. Okay. Given that R is the return achieved, R is the random variable for the return achieved on the investment, and we have been provided that R follows. Now, for the follows button you have on your left side of a keyboard, below the escape button you have this squiggle sign. Okay. So, you keep this normal and we have 150,000, then we have, look, what you can do is, since we have 150,000, so you would be using commas in that also, and we would have to differentiate our sigma and mu also with a comma. So, what you can do is avoid the comma in the numbers, okay, but make sure you place zeros correctly, otherwise you yourself could get confused, okay. And we have been provided, what else we have been provided is, N is the normal 1, 1 random variable, okay. N is where N is a normal 1, 1 random variable, okay. So, let us start with the first part, which is variance of return. So, let me give me the heading of the variance of the part, variance of return, okay. So, since N is a normal distribution, what we can do is we need to find variance of R. Look, once I keep R in the brackets, it goes like this sign, okay, this trademark sign. So, what you can do is Control Z to bring back it to the normal place, okay, is equal to variance of What is the formula for R we have been provided is, let us check. So, for R we have been provided 250,000 minus 100,000 N. So, 250,000 minus 100,000 N. Okay. So, let us write it, 250,000 minus 100,000 N. I hope this is clear. Now, using the properties of variance, what are variance of R becomes, again control Z to bring it normal. So, variance of a constant is 0, so we put it 0, and negative sign we have. So, variance bring it out at positive, so we can write it as 100,000 ka square. For square we again going to the superscript. So, we have control shift plus. If you are using a normal approach and if you do not want to go to the normal superscript, what you can do is you can use just simply this sign, but make sure you are using the brackets then. Okay. This is also considered 100,000 ka square and into variance of N. Now, since N follows the normal 1,1 distribution, it is 100,000 square star 1. So, our answer is 100,000 ka square. Now, what you can do is put in the comma here, and this is equal to 10 ki power 10. Now, bold out a final answer as I usually say. So, this is your variance. Now, as I mentioned, please make sure you are writing the statement of conclusion in your final answers in papers like CS2 and CM2, because they are considered a higher level paper. Okay. So, you can write, so the variance of return is 10 ki power 10, or you can simply write this as 10 ki power 10. Okay. Whatever suits you, that is completely up to you. Why I am writing so much steps is because if you are practicing 100% of the steps, then only you can write 90 to 80% steps in your exams, because there is time pressure, there is a newer question every time you have to think about. So, all these factors contribute into you writing lesser than what you have practiced. Okay. So, make sure you are practicing more, then only you can bring out the desired output in your exam. Okay. That is why I always prescribe to write as much steps as possible while you are practicing typing. This increases your speed as well as your temperament in typing. Let us move on to the second part. Second part asks us to calculate the downside semi-variance or semi-var. Okay. So, let me put the heading of the part, downside semi-variance of return. Okay. So, control U to again go back to normal. Now, since it is symmetrical distribution, we can simply say that it is half the variance. Okay. So, I can write it as since we have a normal distribution, it is symmetrical in nature. Now, please make sure that you need to mention these words that since this is normal, that is why it will be symmetrical and that is why it will be half. This is of 2 marks. Okay. So, these keywords, for example, these normal distribution, this is a keyword for you. So, control B to that, or you can underline it, that symmetrical, this is a keyword. Okay. The downside semi variance will be half is again your keyword. Okay. So, I will also of the variance. Okay. So, these contains, look, this is half mark, this is half mark, this is half mark, and finally your half mark will be what will be the numerical value. Okay. So, the downside semi variance of the return is 10 ki power 10 divided by 2, that is which will become 5 star 10 ki power 9. So, this is your bold out answer. Now, if you are using this sign in your exam and you do not want to go to the superscript, what you have to use is use the brackets carefully. So, this will become simply or 5 star, now bracket before 10 and this. Okay, if you don't use bracket, this is considered as 50 to the power 10. 50 to okay, so now let's move on to the third part of a question. Let's read it. What does it say? So yes, we have to calculate the shortfall probability where the shortfall level is pound 50,000. Now we have this pound sign. So how do you insert this pound sign in my question paper, right? So what you can do is you can save this pound sign in your Word file, because we would have to use it regularly. So what you can do is go to alt equal to, get this equation editor. Now go to this insert sign and insert a symbol of pound. Okay. Once this is done, what you can do is click on this short drop down arrow. Now click on save as new equation. Once you click on this, make sure you give a name to this. So let me give it a name, pound. Okay. Don't enter the space bar until you want to enter a space bar. Okay. Now make sure you are writing it in insert content in its own paragraph and then click on OK. So yes. So now what I would do is, if I want to write pound, what I can do is I can simply type whatever the shortcut you have provided and then click on F3 key. So you can see I get this pound sign here. Okay. So let us now start our part. Now this is valid for all the type of equation that you are doing. So again this and a space bar. Let me give the heading to it. This is, we are calculating the shortfall probability. Control U. So the shortfall probability below. Now again I have to click the pound. Okay, so backslash pound sign and then I click, sorry, not backslash, we simply write pound and then F3. Okay. Yes, I changed back the alignment. Okay. So below pound 50,000 is, what is it? So let me use the equation editor this time. I have done two parts before it. So 50,000. Now I just standardize the normal distribution. So basically we have R minus 150,000, which is our mean, and that is divided by 100,000, because we had 100,000 ka square, na, that's why we are not using a square root here, we are simply removing the square. So now this goes to the denominator and this is less than, again I will use brackets. So 50,000 minus 150,000 and then 100,000 and brackets closed. Okay. Now again this is equal to, now we have to use a phi sign, okay, for the CDF of normal distribution. So look, the PDF of normal distribution is backslash small p hi, okay, but the CDF is capital P but small hi. Make sure equation editor is case sensitive, so make sure you are using the best suitable case to get your symbol. So make sure that CDF is capital P and PDF is small p. So here you have to use CDF, so capital P hi, and then I have to write this 50,000 minus this. So this is basically minus 1. And how do we solve this minus 1 thing? We know that it is symmetrical, so I will write that since normal distribution is symmetrical in nature, what we can do is backslash capital PHI minus 1 will be equal to 1 minus backslash PHI, and this is positive 1. Okay. So what we get is, so R less than 50,000 is equal to 1 minus 0.84134 is equal to control B 0.15866. Now we have used the reference of tables book to calculate this phi 1. So I will also mention this reference. So I will write as normal, this standard normal distribution value it is. So standard normal distribution value taken from tables book, or you can simply write tables book page number this alongside this line of equation. Okay, whatever suits you. So now again writing the statement of conclusion, since we are calculating the probability, so it's better to convert it into percentages. So let me write it. So the probability, I am also explaining the meaning of shortfall probability in my conclusion statement. Okay, so it's better that examiner can understand that you know the concept of shortfall probability. So the probability of the investment return are falling below the threshold of pound, again I have to write pound F3, again I adjust back the below pound 50,000 is approximately, I will approximate into 2 decimal places, 15.87 percentages. So this is the final answer. Now let's move forward to our D part. What we have to calculate in D part is VAR we have to calculate. So we have to calculate the value of value at risk at 95% confidence interval. So let's do it as well. So we have to calculate, either you can write VAR or you can write value at risk the whole, it's completely up to you. Okay, so we know that 95% confidence interval, so we need to calculate the normal distribution value from it. So we can write from the tables book, you can mention the page number according to the new tables book. We have 5 minus 1.6449 is equal to 0.05, that is 5%. Okay, so there is 5% chances that the investment return have the value less than, so I can write it as R. I have to go to the subscript, so let's do it in equationator. For those guys using equationator, I have to use 5%, so this 5% is backslash mu. Again I have to go to the subscript, so again underscore R, this minus 1.6449 from above, 1.6449 sigma, I have to write backslash SIG MA sigma. Again I have to go to the subscript, so I use this R. Putting on the values, I write, what I can do is I can simply copy paste this equation. So I just copy paste it, okay wait, yeah, I just copy paste it and I can change my factors here. This is considered one of the easiest way while using the equationator, that you are using copy paste frequently, since you have to change sometimes only a few parameters in the same equation. So why write the whole equation again and again, it's better to use copy paste. Okay, once you are comfortable in copy pasting and selecting things via keyboard only, that becomes more easier. Okay, and this is equal to minus 14490. So again writing the statement of conclusion, so the VAR is pound I have to use, so backslash pound F3, let it go to F3, don't worry, and 14490, since it is, look, it goes to the left. I have to use this, again I adjust back the alignment at 95% confidence interval. Okay, let's move on to our last part, that is E. Again E signs change to this, so what I will do is control Z, it changes to this, control U, I have to use tail var. In the last part I have to calculate the tail var and check if it is exceeding the conditional var as well. Okay, so let's do it. The var is 14490. So the formula for the conditional var, conditional T var, tail var that is called. Okay, or either you can write it as conditional tail var completely, or you can write it as T var, that's completely acceptable. Make sure that you are writing the short notations, or you are writing the acronyms only for those who are standardly accepted. Okay, those who are those which are mentioned in your books those which are frequently used in your table books as, for example, if you are writing normal distribution, so you can write n for the normal distribution, okay. So this is generally accepted. If you are writing interest rate, so even though you are not mentioning at the start that I is the interest rate, it is generally accepted that small I is considered as the general effective rate, okay. So that's completely acceptable. But if you are using A instead of alpha, no, that's not any standard notation. So you have to mention taking A as alpha, okay. I hope this is clear. So now I have to use the integration here. So let's do one integration via normal equation approach, and let's do one integration via normal approach, okay, so that both the students are comfortable. So 0.05 now have integration. So for integration I have \int space bar. Now I have to put in the limits, because in most probably we are going to get definite integral, so we have to put in the limits. So in the limits, for the lower limit I have to use this underscore sign that is received by shift minus brackets, because I have infinity there, okay, minus infinity there. So minus infinity, how I type infinity is \infty, or you can write it as \infity. There are various notations for infinity, so some might have infinity, some might have infinity, that is completely up to you, please check that. Once you get this, now I have to use the upper limits. So make sure you are not hitting the space bar here, otherwise once it goes to the lower limit you won't be able to place the upper limit, okay. So you have to place both the limits simultaneously. So shift 6 to get this sign, and I have negative 14490 here, so minus 14490 brackets close. Now I hit a space bar. Now you can see we got those limits in the upper and lower limits. Now I hit the, now make sure that this box sign or this grayish sign means that you are still working under the integral, okay. So if you want to work under the integral, use this direction of gray sign, otherwise if you want to escape it, make sure you are using the forward arrow key to move out of this gray sign, okay. So let me write in this gray sign 14490 minus x, and this is fx, and we have dx. Now I want to move out of this integral, because मुझे integral में इतना ही लिखना था, so that's why I use this forward arrow key. Now you can see the grayish background disappears. That's what I wanted. Otherwise, what will happen? अगर आप इसके बाद ही enter or space bar, if you would be hitting enter or space bar after this, situation like this would occur, okay, which was not desired. So that's why I have to move out of this equation, where fx is the PDF of normal 150,000 comma 10,000 का square distribution, okay. Now let's solve it by splitting it into two integrals. So what we will get is, let me do it via normal sign this time, okay. Let me check it, just a second. Okay, let's do it via normal equation this time. So what I will do is, I have minus 14490, this is divided by 0.05, okay. This is integration, basic integration, so you are going to do it yourself. I am just telling you how to type the equation, okay. Now in the normal equation you won't be able to put in the limits in your integration, so it's better not to use the integration sign rather than using the word int simply, okay, without a backslash. So int, brackets open. Now I have to put minus infinity, so minus backslash infty minus infinity comma minus 14490, okay. So this is placing the limits. Now use a colon, use a bracket. Now once you open up a bracket, this sign appears, so Control Z to get back to the normal thing. Now I write whatever I have to write it within the integral. So this is fx if I am splitting, and dx, okay, brackets closed. This is my first integral. Now going back to the second integral, so this is complementary with 1 minus 0.05. Again I write int, brackets open. Make sure that within the integral you are only using this curved bracket, not the square bracket. Square brackets are not considered a standard notation for the integral, Okay, so integral again I have to place in the limits backslash infty minus 14490 brackets close, these are limits, colon brackets open, control Z to remove this sign, and then I write whatever I want within the integral, which is this. Okay, brackets close and this brackets close. Again I have missed a bracket here. Please make sure you are using adequate brackets. People mess up with normal typing only because they are not using adequate brackets. So, what you are writing with your intention may not completely be understood by the examiner from the same intention if you are not using sufficient brackets, that is generally accepted form of brackets. Okay. Now, let us evaluate these integrals. So, let us evaluate the integrals one by one, evaluating the integrals separately. So, evaluating the first integral. So, let us use normal equation at this time, int space bar underscore to get the lower limit, brackets minus backslash infty brackets close, shift 6 to get this sign, again minus 14490 brackets close, space bar. Okay, fx dx. I want to move out of this bracket. This can be expressed in the form of normal distribution because this is basically the CDF. Okay, so normal this is less than minus 14490. This is basically just representation of the integral into a probability form, so that we can simply calculate it via tables book. Okay. Now, just standardize this. So, no rocket science in standardizing, 150000, this is divided by 100,000 brackets closed, and this is equal to probabilities, that is less than minus 1.6449, and we know that this is the 5% point. So, this is equal to 5%. Okay. As we expected, this is the 95% confidence interval. At 95% confidence interval, this is our var. Okay, now evaluating the second integral. So, what is the second integral? Let us put in all. Let us do it via normal approach for those students who are doing via normal. So, int placing in the limits backslash infty comma minus 14490 brackets close, colon this, control Z. Okay, fx dx. Okay, this becomes now if you are using the formula of truncated, let us write using the formula of the truncated normal distribution. This is the truncated normal distribution, first movement of a normal distribution random variable on page 18 of tables. This is I am writing according to previously edition of tables book. You can write it according to the newer version. Okay, I missed a bracket here. Look. Okay, so this becomes 150,000 square brackets. Then we have a capital phi, right? So we use a capital phi, capital phi brackets u dash. So, u dash minus capital phi brackets L dash. Okay, brackets close. We are simply writing the formula here abhi, then we will calculate this. Now, we have PDF. So, small phi bracket u dash again minus small phi brackets L dash. Okay. Now, calculating u dash L dash. So, we get u dash as, what is the u dash? This is 14490 minus 150,000 and divided by 100,000. This is equal to minus 1.6449. Again L dash we are calculating. So, L dash is minus backslash infty which is our lower limits. This is divided by 100,000. Whatever we divide it, whatever we subtract from minus infinity, we will only get minus infinity. So, this becomes my minus infinity. So, the required probability will be. So our finally probability क्या बन जाएगी? This will become 150,000 brackets capital phi of what is u dash? It is minus 1.6449 minus backslash capital phi. This is backslash minus का infinity square brackets minus 100,000. Again this is phi minus 1.6449 minus backslash small phi, and this is minus backslash infinity. Okay. Now we know that CDF, this is CDF, so this becomes this basically becomes 0.05, this basically becomes 0 because there is nothing beyond minus infinity in the left side. Okay, and we can calculate the PDFs using the formula of PDFs. Okay. So yes, let's do first simplify the equation, then we will simply calculate the PDFs. So this will become 150,000 0.05, this becomes 0, so I am not mentioning the zeros. This becomes 100,000 and this will be small phi minus 1.6049, and PDF of a negative infinity is also 0. So this is 0. Okay. So I can write it as simply this. So what I need to calculate is the PDF of, now calculating the density function of normal distribution. So what my phi minus, look, this is capital, so I will write small, and minus 1.6449 is equal to, let us use the equation later this time. So 1 by backslash square root, it's 2 pi in here, so backslash pi space bar. Okay. Now we have everything in the e to the power, so minus 1 by 2 brackets minus 1.6449, and we have a square term of this, again a brackets. Now I bring back to this. So this is equal to 0.10313 if you are using the calculators. Okay. So the final value of integral is, what is the final value? This basically becomes 150 into 0.05 minus 100,000 into 0.10313. This is equal to minus 2813. Okay. Now putting all together the values of two integrals, we get the conditional tail var at 95% confidence interval. Make sure you are writing the confidence interval, confidence level as well, because it is very much significant in case of var, tail var, okay, and conditional var. So this becomes minus 14490 by 0.05. This was our first integral, multiplied by 0.05, again minus 1 by 0.05. This is minus 2813, and this is equal to your pound 41770. So make sure you put in the pound, pound, and then you click F3. Okay, F3 don't work in here, so let's make sure that, let's just copy paste the pound sign. Okay, that's more easier rather than writing this. Oh yes. Simply write it. Yep. Okay, so the overall loss is 14490 plus 41770 is equal to control V for a pound sign, and then we have 56260, and then we bold out this answer. So this was the question. This was a good question where we could cover all types of measures of investment risk. Now make sure, again I am saying that you are writing as much steps as possible, you are giving as much references as possible while you are practicing typing, because at the end of the day when you are typing your answers in your exams, then it's lot more difficult to think and type at the same time, and if you are practicing 100 words, so you will be able to produce only 90 to 80 words. Okay. So yes, this was it for today. Now we would be covering further chapters such as portfolio theory, CAPM and another models like multi-factor models in our next class. Till then, happy learning guys. Thank you.